So my name is Ciaran McDonagh and I am responsible of managing the ICBF methane projects that we have here in Tully and outside on commercial farms. So back in 2018, ICBF purchased its first green feed machine for here in Tully, and since then we now have 12 green feeds here in Tully, and I also have 12 green feeds out on commercial farm, measuring grass data on dairy farms, on the progeny on dairy farms, suckler cows on progeny, and dairy beef, and then on finishing feedlots as well. So that's on grass and the indoor system. So why are we doing measuring methane here on ICBF? So Irish agriculture contributes to 12.1 million tonnes of CO2 equivalent, which is roughly about 37% of the national greenhouse gas emissions. So agriculture plays a big role in terms of the emissions from greenhouse gas emissions point of view, and with national government and EU targets for a reduction of 25% in Irish agricultural emissions by 2030, methane will play a key role as it contributes to that 12 million tonnes of CO2 equivalent. So, but that's roughly about 60% of Irish agriculture methane emissions. So in order to meet our targets, we need to reduce methane in our dairy and beef herd. So when we go out in farms and commercial farms, we're getting data from herds that use gene knowledge, so the most relevant cattle to date in terms of genetics point of view. All that data then we are collecting together, we analyse it with an aim to generate and validate genetic evaluations for methane in the EBI, the ERSA and the commercial beef value for dairy beef cattle. But that aim then is then farmers then be able to breed for lower methane cattle. So basically work by Chagas showed that by breeding for methane, we could reduce methane output by 1% every year, and it's cumulative and it's permanent. Unlike feed additives where it's costly measure, and then if there's an issue with feed additives, then farmers might not be able to get it, and then your emissions go back up again. So that's why genetics will be an important tool for farmers to hit our targets for emissions. So if looking at emissions then, a dairy cow today, in the month of March, out on full-time grass, will emit between 300 and 330 grams of methane per day. If we're looking at a suckler cow then, around 250 grams per day, 300. And then looking at kind of an indoor system here in Tully, of a diet that we have in Tully, kind of a TMR, they were doing like suckler steers doing 250 grams of methane per day. Suckler heifers for finishing are doing around 220 grams of methane per day. And then your dairy type animals are in 250 to 270 grams per day. So methane is linked to feed intake. So every 1 kilo dry matter intake an animal consumes, it will emit between 19 to 24 grams of methane. So more the animal eats, the more methane the animal produces, due to the nature of methane is produced in ruminant. So by breeding for lower methane, there is a potential positive impact of producing more feed efficient animals. Hopefully that's still to be determined, but that's something that my work here in ICBF hopefully might determine if that's the case. So breeding for methane might produce more feed efficient animals, which hopefully be more profitable for farmers. Based on work I have on dairy farms, we're seeing a reduction in methane once they go out on grass. So during kind of indoors in the month of February, probably expect to see around 400 to 450 grams of methane per day on a silage meal diet. And then once you get spring grass into the system, the methane reduced by 20-25%. So by getting more grass in the diet, increasing the days of grass throughout the year, that will increase profitability. It also has a positive impact in terms of methane output on that cow. So that's something that's quite positive, that goes hand in hand, that environmental sustainability goes with financial sustainability for the farmer. Based on data we have here in Tully, looking at a 5-saw CBV animal, you're looking around that animal is eating less, it's eating by 12.5 kilos dry matter per intake, looking at suckler steers. It's producing around 250 grams of methane per day. Because of a higher carcass output, it also dilutes that. So there's 3 ways to measure methane. So you have your grams per methane per day, which you get from your green feed. Then looking at methane yield, looking at the grams of methane divided by the dry matter intake, which we're going to do here in Tully. It's very difficult on commercial farms. But then looking at methane intensity, looking at grams of methane divided by that production. So grams of methane divided by milk solids for dairy cow, grams of methane per carcass weight for your beef animals. So we're seeing that with your high genetic merit animals, high EBI, high CBV animals, that are more productive, so producing less grams of methane per kilo milk solids or kilo of carcass weight, which is again profitable then for the farmer and also beneficial in terms of more carbon footprint in an animal. So as we head into the breeding season, farmers will be particularly looking at type of bulls they use in terms of dairy herd, EBI, or the Ursa index for your beef suckle animals. So the measures continue to select for high EBI, high FISA animals, because they will continue to reduce methane emissions to better kind of efficiencies from the animal, and also then improve your overall fertility, production, in terms of what you're looking for in that animal, either dairy or beef.